we have our cofunction identities, and these are simply saying that the cosine of an angle is the same as the sine of its complementary angle. So to find a complementary angle, we take 90, or in this case pi halves, and we subtract the angle that we have, and that gives us another angle so that our two angles add up to 90, or pi halves, and we can call those complementary angles. So cofunction identities follow this rule. Notice how we have sine and cosine together, because those are cofunction identities. We have cotangent and tangent together. We have cosecant and secant together, right? So all of these are cofunction identities with the cofunctions, and they have to do with the value of that ratio being the same as its complementary angle. So whatever you want to write down about that to help you remember is a great idea. So complementary angles, I'm just writing that down. I don't know, my train of thought isn't organizing it into like really organized thoughts, right? But these are all complementary angles. Pi halves minus theta means theta, and pi halves minus theta are complementary. They're complements of each other. Oops. So the sine of an angle is the same as the cosine of its complement. And the tangent of an angle is the same as the cotangent of its complement, etc., etc. Okay, let's look at example 3, the cosine of 15 degrees. Do you remember what we found for that one? That was like square root of 6 plus square root of 2 over 4, something like that. We're going to use that answer to help us find the exact value of the sine of 75 degrees. Well, the sine of 75 degrees could be rewritten as the sine of 90 minus 15 degrees, correct? Wouldn't that mean the same thing? And if it's the sine of 90 minus 15 degrees, then we can use a cofunction identity. And that means that would just be the same as the cosine of 15 degrees, because 15 and 75 are complements. So guess what the answer is? It's exactly the same answer we found in example 3. We're done. Sine of 75 equals cosine of 15, because 75 plus 15 equal 90, right? If that was a right triangle, oh, it's a very bad drawing of a right triangle. It could have been worse though. And let's say this angle is 15 and this angle is 75. Hopefully it makes sense that since sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, it ends up that those two values are the same, because the opposite and adjacent switch when you switch to the complementary angle. That's why these work.